Today's class, we're going to discuss about authentication, authentication and digital signature, secure hash algorithm. So what is a message authentication? So message authentication, it is verify the authenticity of both the message sender and message content. So and the what is exactly, so verify the authenticity of both the communicating parties, even message sender and message content, the content of the messages and the sender of the messages is verified by the message authentication. Here, message sender is authenticated through the implementation of a digital signatures. So sender will sign the particular document. So it is authenticated through the implementation. That is exactly a digital signature. So message content is authenticated through the implementation of a hash function and encryption of the resulting message digest algorithm. So this the function used to produce the fingerprint of messages. So hash value is added at the end of the message before a transmission. Here, so hash function, so that is exactly to produce the fingerprint of the messages. So like hash value is added at the end of a message before transmission. So receivers recomputes the hash value. So as and when the receive the that is a message content, it recomputes the hash value from the received messages and compare it to the received hash value. So if two hash values are same, the message was not altered during the transmission. If the hash values are not same, the message is definitely it is altered during the transmission. So here once hash function is applied on a message, so any message or the any plain text m, the result is known as message digest h of l. So hash value with the message. So here hash function is the following properties. So unlike the encryption algorithm, the authentication algorithm is not required to reversible. So here, encryption algorithm, you already know that it is conversion of plain text into ciphertext. So here, the authentication algorithm is not required. So it should be reversible. So it is not required. It should be reversible. So here, given message digest, so as and when messages have been digest, so that is a hash with the messages h of m. So it is computationally infeasible. So definitely it is any hackers or attackers, it is a computationally infeasible to find the value of the particular messages because it is already hashed so with the messages. So message digest, it is nothing but. So here, so this is computationally infeasible to find two different messages. So suppose if it is a M1 and M2, so it is a hashed. So message 1 and message 2, it is a hashed. So h of M1 and that is equal to h of M2. So even both are equal. So but computationally infeasible to find the two different messages. So that is a strong hash functions if we are applied. So here, so message authentication can be implemented by two methods. So in the first method, so hash function is applied to messages and then process for encryption so is implemented. So here, so that is a hash function is applied with the message and process encryption is implemented. At the receiver side, as you know that received the message digest is decrypted and compare. So it is a conversion of the again ciphertext into, because already hash function is applied. So it is a hash value with the messages and comparison is made so at the receiver side and message digest is made locally from the received messages. Compare it with the also one made locally as it's a site for any judgment on the integrity of the message. So integrity of the message means so if it is originality of the messages may not be a change. So that is a because it is already hashed with the functions and those functions have been compared. So once it is decrypted and it is compared, so original integrity of the messages can be achieved. So in the second method, no encryption is involved. The two parties share the secret key. So exchanging of secret keys by the two communicating parties. So user 1 and user 2. So hence the receiving side the comparison is made between the received messages, hash with the messages, and the message digest is made locally from the received messages. That is the second approach. So here, whatever I explained so far, so that is available here. That is combined with the encryption key. So here, user one is sending the messages, and that is hashed with the. So that is exactly that is hash functions, and it is applied with the so key and message with the hash of m. So this is the message, and it is a hash of m. Again, it is received at the received the message and hash of m. It is separating the hash functions and message. So you can see that so that is a once it is a message has been separated. So that is a compare. So it is a hash functions. So with the so key has been decrypted with the key. So at the receiver side. So that is exactly so that is a B has been decrypted. So B and B now it is a message and it is compared. So this is exactly so the B. Okay. So whatever it is sending that is a so hash functions and hash functions. So whatever that so that is a comparing has been done. So compare, so there is no changes in the comparison. So your messages, so integrate with the messages is achieved, and so user to so that is achieved there is a integrity. So that is so here without so with key and without key. So messages as usual hash function is applied. So message with the hash function. So it is received as a message and hash function. So message and hash function is separating here. So it is again it is comparing the hash functions. So there is a so and also that is a so that is a received so that is a message. So it is integrated the message is achieved by the user too. So this is how so it is exactly secured hash function is working. So here so authentication and digital signature. The digital signature and the message is required for the authentication and identification of the right sender. Who is exactly a right sender? We can identify so with the help of digital signature. So RSA algorithm can be used to implement the digital signature. As you know that there is a publicly cryptography algorithm. RSA algorithm can be used to implement this digital signature. The message is encrypted, so with the sender of private key, thus the entire encrypted messages serve as a digital signature. So before sending a message should be encrypted. So sender's private key using the sender private key and the entire encrypted messages serve as a digital signature. At the receiving end, the receiver can decrypt again. It is a so encrypted messages to be decrypt the messages using public key. This authenticates the packet comes from the right users because it is a public key has been taken as a so it is a so key distribution center or it is a public registers so center it is available. So it is always it is taken so that is a public key so by the at the receiver side. So opposite person public key will take. So this authenticate that the packet comes from the right users. So again, secure hash algorithm. So the secure hash algorithm was proposed as a part of digital signature standard. So SHA-1 version 1, the first version of this standard takes some messages with a maximum length of here. The takes what is the maximum length is so 224 and produces 160 bit of digest. So with this algorithm, so SHA-1 uses the file registers R1 through R2 to maintain the state of 20 bytes. The first step is pad messages with a length of LM and message so length is posted with the LM that is a 448. So that is exactly a 448 mod with the 512. So other words, so that is the length of the padded messages becomes 64 bits. So here, so length of the padded, so that is so the first step is to pad the messages. So length of the padded messages is 64 bit less than the multiple of 512 bits. It is exactly correct. So it is a so length of the messages is 48 mod on 512. It becomes the 64 bits and less than this multiple of 512. The number of padding bits can be as low as 1 bit and so high as 512 bits. The padding includes the 1 bit and as many 0 bits. So it is a so binary bits. So as low as 1 bit and it is a so it is a padding includes 1 bit and as many as many 0 bits as required. So here, therefore, the least significant 64-bit length it is appended to convert the padded messages to a word with a multiple of 512. After padding, the second step is to expand So each block of 512 bit, so 1632 bits and so words. So M1 to M15, the words of so that is 80. So and 32 bit using so WY and MI for 0 is less than or I less than or equal to 15. So this is how WI minus 3. So exclusive or with the WI minus 8, I minus 14, I minus 15. So that is a one for 16 is less than or equal to I and 79. So where J, so this is the J means left rotation of j bits, and this is the way it is shifted several times. Incoming block is mixed with this state. So next bits of the each block mixed with the state of four states steps and maintaining the 20 words for any values of a and b and bits of number I. We can define the function. So that is abc as follows. So you can see in the next slide how the function which is defined. So again so it is so these functions which is defined in the so 20 and 39, 40, 59, 60, 79, that is a range is given. This 80 steps, so, so from 0 to, so that is 79 and 4 rounds are described here. So this is the 4 rounds exactly follow R5 is equal to 4, 4 R3 and R3 is equal to R2 and R30, R2, R1 and R1 delta. So CA is a constant value and specified by the standards of round high. The message digester is produced and concatenation of the values in R1 through R through. That's all about this SHA. In this class, we have discussed about the authentication and digital signature, and secure hash algorithm.